Energy Workbook, page 13, question 4. 3 kilograms of water at 35 degrees Celsius is added to 500 grams of water at 42 degrees Celsius. What is the final temperature of the mixture? So the first thing we're going to do is we're going to write down our givens. So our mass 1 is equal to 3.0 kilograms. Our T of 1 initial is equal to 35 degrees Celsius. Our mass of 2 is equal to 500 grams, which we know is equal to 0.500 kilograms. Okay, and our T of 2 initial is 42 degrees Celsius. Our other value that we know is our heat capacity constant, or C for water, is equal to 4.18 times 10 to the 3 joules per kilogram times degrees Celsius. Okay, let's reflect on the equations we know. We know our change in energy of 1 plus our change in energy of heat, of 2 is equal to 0. We also know that our change in heat energy is equal to mass times heat capacity times your constant heat capacity times your change in temperature. So we're going to combine these two equations to get your mass of 1 times your heat capacity of 1 times your change in temperature of 1 plus your mass of 2, your heat capacity of 2, and your change in temperature of 2 is equal to 0. Perfect. So now we're going to expand this out. So our mass of 1 times our heat capacity of 1 is equal times our T of 1 initial, or our T of 1 final minus our T of 1 initial, plus our mass of 2 times your heat capacity of 2 times your change in temperature to final minus your change in temperature of 2 initial is equal to 0. Okay, we want to find this T final. We know they're both going to be the same, T1 and T2, because it's a mixture and they're combining together and their heat's going to cancel each other out. So we're going to expand this out even more so that we can remove the brackets. So our mass of 1 times your heat capacity of 1 times your temperature final of 1 minus your mass of 1, heat capacity of 1, temperature of 1 initial, plus, this is a minus sign if you can't tell, plus your mass of 2, heat capacity of 2, and your temperature 2 final, minus your mass of 2, heat capacity of 2, temperature of 2 initial is equal to 0. Okay, now that we've gone this far, we're going to isolate our T2. So our T2, or our T final, because they're both going to be the same, is going to be equal to our mass 1 times heat capacity 1 times temperature of 1 initial plus my mass of 2, heat capacity of 2, temperature of 2 initial divided by my mass of 1 times my heat capacity of 1 plus my mass of 2 times my heat capacity of 2. Okay, now that we've got this far, it's important to notice that because all of this water is in the same state, it's all in liquid, these heat capacities are all going to be the same. So we're actually able to factor out our heat capacities so we can cancel all these heat capacities out. Okay, this simplifies our equation a lot. So we now have our temperature final is equal to our mass 1 times temperature 1 initial plus my mass 2, temperature of 2 initial divided by my mass 1 plus my mass 2. Okay, now that I've made an equation for myself, I'm now going to sub in my values and solve for my final temperature. So my temperature final is equal to 3.0 kilograms times 35 degrees Celsius plus 0.500 kilograms times 42 degrees Celsius divided by 3.0 kilograms plus 0.500 kilograms. Okay, and when we plug this into our calculators, we are going to get the answer of 36 degrees Celsius. And we'll notice that our kilogram units cancel out and we're left with our degrees Celsius as our units. So now our very last step is to simply write a therefore statement. So therefore, the final temperature of the water is 36 degrees Celsius.